Hi again, this is Jeff, your ProtoPie expert answering your ProtoPie questions. Today's question comes from John. John asks, I'm looking for a way to connect my Arduino to my Pi, but I don't subscribe to the Enterprise plan. Is this possible? For some context, we received this question back in March when the only way to work with Arduino was through a companion product called ProtoPie Connect available only to Enterprise subscribers. But since then, there have been some very exciting developments. Number one, ProtoPie Connect is now available to both Pro Plan subscribers and Enterprise subscribers. And number two, we partnered with Blokdots. Blokdots offers a no-code solution for working with Arduino, and they have built-in integrations for both ProtoPie Connect and ProtoPie Player, meaning that even if you're on one of the old legacy individual plans, you can still work with Arduino. And I'll show you how both of those work. Lastly, I'm going to be working with this. This is something called a Grove board. It's by a company called Arduino Labs. And this makes wiring up your circuit incredibly easy. And in fact, no wiring is necessary at all. Things are built right in. We've got a button here, we've got a potentiometer here, we've got an LED here. You don't have to wire everything up. So if the thought of wiring up your own circuit intimidates you, don't worry. I'm going to show you how to do everything using this board here today. Ready? Let's jump in. Our first example is a shoot-'em-up style video game, and this was a demo that was made by Sanju, one of our ProtoPie Connect members, and he did this as a demo for Oculus, and it's actually really cool, and I suggest you check it out. I've taken a slimmed-down version of this just to show you how we can add control. What I'm going to do is with my Grove board here, I'm going to use this button and this knob that you can turn. This is called a potentiometer, and as I turn this, I'll be able to steer my shift left and right. I don't want to code this, so I'm going to use something called Blokdots. This allows you to set up Arduino programming without writing any code at all. This is a visual if this then that kind of format. First thing I'm going to do is I'm going to plug in the board via USB. If this is the first time you're going to run Blokdots with your board, it needs to put on a special firmware. And there we go, all done. Great. Now I can start to use the components that are on here. Now the really cool thing about the Grove board here, let me see if I can move this to a place where you can see it. It's labeled on here how things are hooked up. So for example, if I want to use a button, I'm going to connect a component called button, and it's asking where it's connected on the board. And it's printed very clearly, it's on D6 or digital 6. So I'm going to choose D6 from the drop-down, and I'm going to click Set Component, and now I should be able to use the button. When I click that, you're going to see I get feedback. I press it down, it turns to 1, I let go, it turns to 0. There we go, I've got that coming through. I'm going to add the potentiometer in the same way. Connect the component, and if you can't find it, you can just type in a little short list. So I want potentiometer, and this is on A0 or analog 0. Set component, and I should be able to turn this left and right, and you see I have a value. All the way to the right, the value is 0. All the way to the left, the value is 1023. I'm going to use this to steer my shift left and right. And the last thing I need to do is add the integration. I'm going to use the ProtoPie Connect integration. There's also one for ProtoPie Player. So if you don't have access to Connect, say you're on one of the legacy individual plans, you can use the ProtoPie Player integration. I'm going to show you later how to do that. But for now, we're going to use Connect. Let's set up our logic now. I want the button to send a fire message to ProtoPie. So I'm going to say, use this button, and let's rename this. We'll call this Fire Button. If Fire button is pressed one time, then ProtoPie Connect should send the message fire. And let's do the same thing for steering. I'm going to use this one in my logic here. I'm going to call this steer control. If steer control is changing, that's what happens when you're twisting it left and right, then ProtoPie Connect should send the message steer. And I don't have to do anything else. This will automatically send the value along with it. So as I turn this left and right, so if I go all the way to the right, you're going to see it goes down to 0. And if I go all the way to the left, it goes up towards 1023. And I can see this in action. So what I'm going to do is, first of all, I'm going to move this over to my other screen here. I've got Connect open over here. So let's take this, we'll go over to this second desktop, and I'm going to move this over here so you can see these side by side. And make it a little bit smaller so you can see this is ProtoPie Connect over here, by the way. And if I run this, I should now see messages coming into ProtoPie Connect. So if I press the button, there we go, the fire message comes through. And if I turn the potentiometer all the way to the right, you're going to see it's going down to 0 or close to it. And if I turn all the way to the left, it goes all the way up towards 1023. So there we go. My entire Blokdots project and therefore my Arduino integration is set up. All I need to do now is change my Pi to accept these messages. So let's go back into Studio. And I'm going to add a receive. And whenever you receive a message through ProtoPie Connect, you need to use the ProtoPie Studio channel. And the message, the first one we made up was fire. And I want this to do something. Now, if I take a look at my game logic, you're going to see I have a receive here called fire missile. So I'm just going to send that message, send to current scene fire missile. And it's a good idea to rename your triggers and responses. So you're seeing fire from Connect. I'm going to send fire missile to scene. Okay, let's see this in action. I'm going to save this. And over here, I have Connect open, but I don't currently have my Pi running through there. I need to add it in. So I have it here. I'm just going to drag it in, shoot 'em up Pi, and I'm going to preview it. Now, you can preview it a number of different ways. I'm just going to preview through the browser here, but you can preview on a device using the QR code. Let's say you wanted to run this on a tablet or something like that, or on a phone, you could do that, or on a USB connected device in the same way. But I'm just going to run it through the browser. Okay, if I now click this start button, I should be able to fire the missile. If I press the button, there we go. That's working. Now I can't yet steer. Let's set that up next. Back in Studio, let's add another receive. And this, once again, will be through ProtoPie Studio. The message is steer. And steer is coming with a value, so I need to assign that to a variable. I don't currently have one, so let's make one. And I'm going to call this position. Receive, steer, assigned a variable, position. And let's rename this. Receive steer from Connect. And then I need to do something with it. I'm not going to do it here. Instead, I'm going to use a chain trigger. I'm going to chain the value. So when I'm all the way, let's go back to Blokdots here for a second. So if I open up, bring up Blokdots, and you're going to see when I turn it all the way to the right, my value goes down to 0. And if I turn it all the way to the left, my value is 1023. What I'm going to do is I'm going to use the chain to map whatever value is coming into pixel coordinates on the screen. So let's go back to Studio, and I'm going to take this fighter object right here, and let's see. Now it looks like I'm not moving it, so the one you see here is actually part of the intro video. You don't actually show the actual fighter until after that video starts. But if I turn the opacity on, you're going to see it's a separate object. I'm going to move it all the way to the left. And let's move it in a little bit, and we'll round this to an even 75. So all the way to the left is 75 pixels. And let's take a look at what it looks like all the way to the right. Move it in a little bit, and we'll round this to an even 1290. So all the way to the left, 75. All the way to the right, 1290. We're going to put you back in the center. Set the opacity down to 0, and let's set up our chain. Add trigger, chain. I'm going to chain the value of position, and based on that, I'm going to move the fighter. Select layer, fighter, and when my range is 1023 all the way to the left, therefore it will be 75x, and when my value is 0 or all the way to the right, I'm going to use 1290. The way chain works, ProtoPie will automatically map all of these values that are in between 1023 and 0 to values in between 75 and 1290. Let's chain position and move fighter. And that should be everything we need to do. Now, whenever you have a Pi open in Studio and in Connect, a live link is maintained between the two. So when I save this, my version running in the preview over here is automatically updated. So now I should be able to steer my ship. So let me start this. And as the game starts, there we go. I can now move the ship left and right. Okay, you did notice that the ship starts all the way on the right, and that's because the initial value for steer is set to 0. So let's fix that in ProtoPie. So the initial value for position, not steer, it's set to 0. Let's put that halfway between 102.3 and 0, and that would be 511. Now I'm going to save this, and you can see when I start, and if I don't touch the Grove board, my ship should start right in the middle. There we go, very good. Now if I move the steering over, you're going to see it starts to move. The problem that we had though was that my potentiometer was all the way to the right. So the second I started to turn it, the value changed, and it changed to something over here. So we also want to be cognizant that we keep it somewhere in the middle. So I'm going to keep the ship there, and let's restart this. There we go, I'm ready to go, and if I start steering, it started more or less from the center. And now we can fire on these guys. All right, notice how I have this start button that you have to click with the mouse, and I've done this intentionally. I could have set this up so that way I could use the fire button to start, but let me show you what happens if I do that. So I have this variable called started, and I'm going to change my start game logic here. And I'm going to assign the value 1 to started here. And I'm going to make a decision. So if I receive the fire message coming in from Connect, if the value of started is 0, then I'm going to send the message to start the game. That's what this does right here. Or if the value for started is 1, then it's going to send this fire missile to scene. So condition started equals 0. Game is not started yet. I'm going to send this, copy this, pop you under here. Otherwise, if the value for started equals 1, which it will be because my receive start game now does that. That's what I added right here. I'm going to take you and put you under here. So the first time I press fire, it's going to start the game. Any subsequent ones will fire the missile. You're going to see what happens when I do this. Watch this. Save this. And let's go over here. And if I instead don't click the start button and I press the fire button on the Grove board, now, when I move back and forth, notice how I don't have any sound. Now, this is not a problem with ProtoPie per se. It's a problem because we are previewing this in the web browser. And modern web browsers have very strict restrictions on when sound can and can't play. And generally, the rule of thumb is sound can't play automatically. It can only happen as a result of direct user input. So if I change this and I hit the start button manually, this click counts as direct user input. There we go, I've got my rocket blasting off, and you heard the sound there, and if I steer, now I have the sound. All right, let's add one little cool thing to this. I've set this up so that way the missile can be steered or not steered. Right now the missile fires in a straight line, and there's a condition on here. When the missile is flying, this value for fire turns to 1, so that way it doesn't change the position of the missile as it's flying through the air. We can change that. So if I turn off this condition and I turn on this one, we can actually steer this missile now. Now this will work similar to any game you might have played in the 80s and 90s. Where you could steer your missile after you fire it. So let's save this. All right, let's see how this works now that I can steer my missile. I'm going to start this. And when I fire, let's wait till let these guys get on screen a little bit here. When I fire, I should be able to move my missile, and maybe I can pick up a few of these guys in one shot. I got 2 there. Missed completely. There's 2. There we go. Let's see if I can get a bunch in this next wave coming in. There, 2 there in one shot. 2 there. Let's go for 4. See if I can get 4 in these green guys. Oh, I got 3. Pretty close. The second example I'm going to show you is a smart home app. And in this case, this is a mobile app that we can use to control our air conditioning. Now, this app already has mobile control built in. I can turn the system on and off with this button right here, and I can drag to change my temperature control. And it's to a maximum of 36 degrees and a minimum of 16 degrees. I'd also like to have this such that I can control this with my Arduino. And this is to simulate maybe a wall control on the thermostat. So we could use the exact same items we used before. Use the button for the power button and the potentiometer for the temperature. And let's do that. Let's set that up exactly that way. So first thing I'm going to do is I'm just going to clear all this. So File, New Project. Not going to save this. And I'm going to keep the button and the potentiometer. So the button will be to turn our system on and off, right? So let's use that. If the button is pressed 1 time, then, oh wait, we need to add in our integration for ProtoPie Connect. Then ProtoPie Connect should send the message on, off. And then for potentiometer, now the Pi here works on temperature. As my temperature changes, the display changes accordingly. So I could have the potentiometer mapped to different values of the temperatures in here, right? So let's do that. I'm going to use this in here, and if potentiometer is changing, then ProtoPie Connect will send the message temperature. And remember, all the way to the right, the value is 0. All the way to the left, the value is 1023. Let's add in the logic for that. So receive from ProtoPie Studio. The first one is on off. And let's use this to change the value of power. So condition, if power is 0, then I'm going to set it to 1. Assign, select variable, power, set it to 1. And in fact, I'm doing exactly the same here as tapping the power button. So why don't we just copy these 2 instead? Remove that, and I'm just going to paste these here. I want the same thing to happen. So I'm just toggling the value of power. The Pi responds to, in here, thermostat logic. It detects the value of power, and it does a bunch of things. Okay, let's save that, and we should now be able to turn our thing on and off. So let's go back to here. We'll add in the air conditioner. Let's bring that up in the preview, and we'll make you a little bit larger over here. And I'm gonna run this, and I should now be able to press the power button. There we go. I'm pressing the power button, and you can see here, let's clear this so you can see this over here. There we go. The message on off has come through, and you can see a bunch of other things have happened too. We're going to deal with them. We're going to work with them shortly. But press the on off button once, it turns my air conditioner on, and I can turn it off, and it stays in sync. So if I click it over here to turn it on, the next click with the on the Arduino will turn it off. So this is all working great. Let's do the same thing with the temperature. Let's do a receive from ProtoPie Studio, and what did we call it? We called it temperature. Let's just copy it so I don't have a spelling error. Receive temperature, and I'm going to assign this to a variable, and we'll call this P input, for short for potentiometer input. Like we did before, I'm going to add a chain, and I'm going to chain the value of P input, and I'm going to use it to update our temp value. So the temp variable is what controls everything in here. So as this goes up and down, the display goes up to say 24, 25, 26, and it adjusts the circular display here. So chain p input, and we'll assign a new value to temp. And remember, all the way to the right is 0, and all the way to the left is 1023. So 1023, my value for temperature is at its minimum, which is 16 degrees. And all the way to the right, my value coming in is 0, and I'm going to assign that to 36. Let's save that, and we'll go over here. And now let's see what happens when we turn. Okay, so first of all, we're getting decimals in here, but let's not worry about that for a second. I want to demonstrate the issue that we're going to run into. So as I turn this, so let's say I turn this all the way to the left to go to my minimum temperature. Right, it's almost there, but it's not getting quite all the way, but don't worry about that. And then I drag this myself. So I'm going to drag this up to 25 degrees. And now I want to turn it down using my manual control here. I can't do that because my potentiometer is already all the way to the left. I can only turn it to the right. And you're going to see when I do that. By the way, when I did that, and I'm going to drag it out using the phone control, and you're going to see when I start turning it to the right, it doesn't increase from 25, it starts from 16. And that's because the potentiometer is finite. It has a minimum value and a maximum value. I would like instead to be able to turn this knob without a limit. I just want to know that if I turn it to the right, I'm going to increase the temperature from where it is, and if I turn it to the left, I want to decrease the temperature from where it is. I'm going to use something different for this. So, Grove has a little trick up of its sleeve. We take a look at this. Notice on the Grove board, there are all these sockets in here. And these allow you to expand it to add on devices that are not on here. This is something called a rotary encoder. And the way that this works is if you click it, you might not have heard the name before, but you've definitely used one before. Volume control on a stereo system, for example, or in your car, where you can turn it and you can feel a click. There's physical positions it can get to. And the thing about this is you can continue to rotate this in either direction indefinitely. And instead of it being based on position, we're going to use whether it was a click in the counterclockwise direction to turn our temperature down by 1, or a click in the clockwise direction to turn our temperature up by 1 degree. This is something you can buy. You can buy this from Arduino's website. You can find these things on Amazon, or there are other sellers you could do. But as long as you buy things in the Grove system, you're going to see it has the same connection socket on the back of it right here as it does on the board. And your Arduino kit, with the Grove beginner kit, comes with a number of these wires on here. And you're going to see they have these wires on here, and they only fit in one way. So I can plug this into my encoder here, and I can plug this into one of these sockets on the board. Now, the only thing I need to be careful of is that I'm not plugging it into something I'm already using. Now, in this case, I'm using the button on D6, and I'm going to be using a couple of other things. I'm going to be using the LED, and I'm going to be using the buzzer. The LED is on D4, and the buzzer is on D5. So I can plug it into the very first digital, that's D2, and that's this one right here. And it only goes in one way. You can't mess this up. Now, I know I did say that no wiring is required. It's not quite true because you have to do this, but I'm sure you can handle plugging this in. You don't have to understand how it works. You just got to know, plug it into a socket that you're not going to be using on the board. Now let's go back to our Blokdots integration. And I'm going to remove the potentiometer here. So I'm going to remove this card. I'm going to remove this guy. And I'm going to instead, let's make this a little bit bigger so we can see it here. I'm going to add rotary encoder, and it is just called encoder in the list here. Encoder, and remember, it's printed on the board. I have it plugged into D2 or digital 2. So let's use digital 2. I'm going to set that. And now I've got a different display here. Rather than, here, if I turn my potentiometer up and down, you're going to see I have a one of 1024 preset positions based on where I've turned it to. If I instead turn the encoder clockwise, it goes up by 1, 2, 3. It just goes up by 1 at a time. For every click, it goes up by 1. And if I turn it counterclockwise, it goes down by 1. And it'll go -2. So if I continue to turn it downwards, you can see it goes negative. I don't care what the value is. I just care that it is either counting upwards, like this. Here, if I reset that to 0. I care that it's counting upwards. So if it was the previous value was 0 and the new value is 1, and that's a click in the clockwise direction. And if it's going from 1 to 0, that's a click in the counterclockwise direction. This is all I care about. So I don't care what the position of this rotary encoder happens to be at. I just care about the change. So let's get rid of the potentiometer. We're not going to use it. I'm just going to get rid of it altogether. And instead, let's use the encoder. If the encoder counts up, it's not exactly proper English, but if the encoder is counting up, then ProtoPie Connect, I'm going to have it send the message temp up. And similarly, if it's counting down, I'm going to send the message temp down. So if the encoder counts down, then ProtoPie Connect sends the message temp down. All right, whenever you make changes and you got your project running, you have to stop it and restart it. And let's just make sure that it's working. So I'm going to clear the output coming through into Connect. And let's press the button once. I get the on-off message coming in. And if I now turn the encoder, I'm going to clear it again. We should see either temp up or temp down. So there's temp up, I'm turning it clockwise, and I should see temp down if I turn it counterclockwise. And there we go. The value here doesn't matter. I just care if I'm getting the temp up message or the temp down. And I'm going to use that to increase the value or decrease the value of temperature in my Pi. So let's get rid of this receive altogether. These two are no longer needed. Let's rename this so we can tell the difference what's going on. Receive on off. I'm going to add the trigger. I'm going to add a receive trigger, and this will be from ProtoPie Studio. And this will be temp up. And I want to increase the temperature as long as the current temperature is less than 36 degrees. I don't want to go higher than 36, so I'm going to make a decision here. Condition, select temp is less than 36. And if so, I'm going to increase it by 1. Assign value temp plus 1. Very simple formula. And this is receive temp up. And I'm going to do the same thing for temp down. Let's just duplicate this. We don't like redoing our work, so let's duplicate. I did that with Command D or Control D on Windows. And I'm going to change this to temp down. And my condition instead is if it's greater than my minimum value of 16, I'm going to decrease it by 1. So temp minus 1, not plus 1. Now if I save this, I should be able to control my temperature through my Arduino here now. So I'm going to grab the encoder, and if I turn it once in the clockwise direction, you can see my temperature went up by 1, and I can keep going. And it should go all the way up to 36 and not go up any further if I continue to turn clockwise. And you can see it didn't. Now I'm going to turn it counterclockwise. I should be able to go all the way to 0 or all the way to 16 degrees and no lower. There we go. I can't go any lower than 16. Now the nice thing about this is the position of the actual encoder on here, it doesn't matter. It doesn't matter what it's been rotated to. I just care that it is either counting upwards or downwards. So if I change now my temperature using the app, so let's say I drag this out and I go up to 26. If I want to turn it down again, one click counterclockwise is going to go to 25. And there we go, that worked. And if I want to go upwards, one click will go up to 26. So using the rotary encoder, I can use the relative value to change it from there, as opposed to using a finite place depending on where I've twisted it to. All right, we've got one problem here we need to fix, and it may not be obvious yet, but I'm going to show you. So let's say I turn it off, and I can turn it off either by clicking the power button here, or I can press the button on my Arduino board. Both of them will turn it off. You're going to see I can still adjust the temperature with the Arduino. I can't with the app because it has been created such that it only allows me to drag to change the temperature when it's on, but my Arduino has not. So it's always going to be able to change the temperature regardless of whether my system is on or not. So we need to make a little bit of a change into our Pi. So let's go in here, and I'm just going to add a condition. We already have a value for power, and I'm going to turn that on so you can see. When it's on, power equals 1. When it's off, power equals 0. So if I save this, and we go back over here, you're going to see that if I turn it off, power is 0, and if I turn it on with the Arduino, you're going to see it toggles it on and off. I only want to allow changing the temperature when the value of power is 1. So let's go back into our Pi, and we're just going to add, let me close these guys up here. I'm just going to add a very simple addition into this condition. So if power equals 1, and same with this one down here. Power equals 1. The way it works when you combine extra conditions in here, all of these need to be true for any response I need to fire. So it will only decrease the temperature if the temperature is currently greater than 16 and power equals 1. And similarly, I can only increase the temperature by 1 if the current temperature is less than 36 and power equals 1. So my temperature cannot be modified this way if the value for power equals 0. So let's save this. Let's just make sure this worked. All right, so I should be able to adjust the temperature. I can click it once. There we go, that's working. And if I go back the other way, I should be able to decrease it. Now if I turn it off, now the value of power is 0, and I shouldn't be able to adjust the temperature. And there we go, you can see I am turning the encoder, but nothing is happening. So there we go. That's a neat little way to add in two-way control here. I can control it both with touch, and I can control it with a physical knob. And this would be similar to how your system would work at home. You might have your thermostat on the wall where you can adjust the temperature, or you can open up your app and you can adjust the temperature that way. Now, some other cool stuff that you can do with your Grove board. So there's some other items that are built in. So there's an LED that is built in, and there's this buzzer that's built in. You're going to see if I hold this up in the camera, you might see there's the LED up in here and there's a buzzer. This will make a sound. It would be nice if we can have this give us some audible and visual feedback. So while the system is on, I want the light to turn on, and every time the power state changes, I want the buzzer to make a chirp. This one to go beep. We can add that in. So I take a look at thermostat logic here, and I take a look at this detect for the power state. You're going to notice that there is a send that's sending this message buzz out through ProtoPie Studio, and you're going to see that when the power turns off, or that the value of power goes to 0, I'm sending the message LED off, and when the power state goes to 1, the LED on message comes through. And you might have seen that come through in through here in Connect. Let me clear this so you can see. If I hit the power button once, there we go. The LED off message came through and the buzz message came through. We can respond to that. We can respond to that in Blokdots. It's not just one way. So we can have messages coming from our Pi, and Blokdots can respond to that. So let's add that. If ProtoPie Connect is receiving the message, and we're going to use the message buzz, then, so now we don't have anything that can output anything yet. We need to add in these components. So let's add in the buzzer component. And buzzer is connected to D5 on the board, and it's already selected. Set component. And let's add in the LED as well. LED, and it is connected to D4. Let's turn these on. I should be able to use it now. There we go. It's now displayed in my list. The buzzer should beep for, I don't want 1 second, that seems too long. Let's change this to milliseconds, which we can do, and we'll shorten it to 300 milliseconds. So about 1/3 of a second. And let's handle the LED state. if ProtoPie Connect is receiving the message LED on, then LED should switch on. And we'll make another one for if ProtoPie Connect is receiving the message LED off, then the LED should switch off. And that's it. That's all we need to do. So I'm going to hit the stop button and I'm going to restart my project. And now we should be able to hear an audible beep. I'm going to hold it close to the microphone so that way we should be able to hear the beep. There we go. Did you hear that? And it'll work the same way if I press the button on the board too. And I don't know if you're noticing, but the LED is going on and off as well. So when it's on, there we go. You can see the LED go on. And when it goes off, the LED goes off. And there you go. So this is a really quick and easy way to add two-way control into your Pis. And I've showed you now how to deal with a Pi that has both touch control and control coming in from an external source, such as the Arduino. And I've showed you how to communicate with back to the Arduino to make it do something. Say you don't have access to Connect. Perhaps you are on one of the legacy individual plans. It's still possible to work in this manner. Blokdots gives us an integration directly through ProtoPie Studio. Now this requires that you have to run your Pi through Player, so on your device, and let's set that up first. So I'm going to reveal the QR code, and I have my phone over here is mirrored through QuickTime, so you can see what's going on. I'm going to scan the QR code. You say I have the Pi, and I can interact via touch with this now. So I can drag, and I can change my temperature, and I can turn things on and off. Now you're going to notice, though, even though I have Blokdots running and everything is connected, if I press a button, for example, that's not changing the power state on my Pi or on my air conditioning system, nor can I control the temperature with the encoder. Even though you're seeing it here, you're seeing the input happening, it can't be received by my Pi because I'm not using Connect. There's an integration for ProtoPie Player as well, so I'm going to use that instead. Now I've got Connect and I've got ProtoPie Player. All of these ones that say ProtoPie Connect, I'm going to change to ProtoPie Player. This one, this one, this one, this one, this one, and this one. There's one more step I need to take, and that is I need to scan this QR code right over here with ProtoPie Player, so it needs to know what to listen to. I'm going to exit out of the Pi on my phone here, so that's two-finger double tap to raise this menu. I'm going to hit exit, and see where it says scan QR code. I'm going to open that up again, and I'm going to scan this one down here at the bottom. And now you're going to see I've got not only my Pi, but I've got Blokdots connected as well. And now if I run my Pi, I should have a full connection. And you can see I've got the green light down here, one connection. Now let's run the project. I should now be able to control my Pi with my Arduino. So if I press the power button, there we go, look at that. It's turning everything on and off. And if I turn the encoder, I should be able to change the temperature. There we go, and everything's working. And my touch control still works. So if on my phone, if I tap the power button, you're gonna see it turned off. And I turn it back on. And my LED state is in sync. So if I turn it on, the LED comes on. If I turn it off, the LED comes off. And I can adjust the temperature here and still have full control with my encoder through ProtoPie Player. So this is a great solution if you don't have access to Connect. If you're on one of the legacy plans, you can still integrate your Arduino with a ProtoPie project. You just have to use the ProtoPie Player plugin in Blokdots. There you go. Easy as pie. No code, no wiring, well, very little wiring. Very easy integration with Arduino and your Pis.